Lock in usually within 30 seconds. All right, so topic of the day. Continuing more with the server administration stuff. It's backup and restore. So far we talked about securing your database, making sure people can't get at it, make sure no bad things happen. But in case something bad does happen, you should have something called a backup in place. Yes, and the screen is on. That has happened before. I forgot to turn on the screen. So today I'm going to talk about backups and the restore, the definition, the kinds of backups, some strategies, and a few things that are specific to backups in MySQL. Is that sound coming from outside? No, it's coming from the air, from the vents. So the thing is with every database server does its backup and restores differently. No two servers do the same thing. Therefore, this slide is more about the generics of it, plus a few examples for the lab. All right, so backups. So you guys probably know what a backup is, so I'm not going to spend a lot of time describing the definition of a backup, but the official definition, it's a procedure for making extra copies of the data for the purpose of restoration in case of loss or damage. In other words, your computer commits harikari and you need to get your data back. If you have a backup, the problem is easy. If you don't have that, your problem is hard. So when we talk about database backups, and this applies to all things, not just database, this applies to servers in general, or even your desktop. Because I remember way back in the day, when computers were very unreliable, putting air quotes around the word unreliable, we actually ran backup software on people's computers. So at night, when they went to go home, they left their computers on, and we'd actually back up their hard drives. Before we had things like OneDrive, Google Drive, OwnCloud, whatever, Sugar, whatever it is you use, right, for backing up your documents. We actually backed up people's computers to make sure that we didn't lose anything important. So when we talk about backing up computers, there are three kinds of backup. There is a full backup. It's known as a level 0 backup. It's a complete copy of a partition. So if we talk about your Windows laptops, it's a complete copy of your C drive. The whole thing gets backed up. The entire terabyte, 500 gigabytes, whatever you've got, the whole thing gets copied. They're pretty chunky. On Macs, it's anywhere from 256 megs to 256 gigs to a terabyte. And with the Macs, you're backing up a partition, which Macs don't have drive letters, but there are partitions. They're just kind of hidden from you. We have incremental backups, known as a level 1. The incremental backup only backs up the files that have changed since the last full backup. So commonly in business, a full backup is done on Sunday because it takes so long. they're so big. Then we'll do an incremental backup on Monday. So at the end of the day on Monday, say 10 o'clock at night, and nobody's working anymore, we will do a backup. And it'll only back up the files that have changed since Sunday. So that's known as an incremental backup. So that backup will be slightly smaller. And then we have something called a differential backup, which is the level 2, 3, 4. The differential backup is the backup of the files that have changed since the last backup, but it might not be necessarily, see, I was right. It'll be the files that have changed since the previous backup, whether it's a full backup or an incremental backup. So just to give you guys an idea of how much data we're talking about. If we decide to do a full backup every single day, because that's the only option we have, and it's 2 terabytes of disk space that we're backing up, that means at the end of a week we'd have 17 terabytes of data. It's a lot of data, right? And space is expensive. People don't really realize just how much disk space costs. And enterprise disk space is very expensive. Like a 6 terabyte NAS drive is usually 30% more expensive than a 6 terabyte Western Digital Bluetooth. Why? Because it's designed to be more reliable and it has a longer warranty period. Now, if we are talking about doing an incremental backup, on Sunday we do 2 terabytes because we're doing a full backup on Sunday, right? On Monday, there has been a 1 gig of files that have changed on Monday. So the Monday backup would be 1 gig. How would you bring yourself back to a working state? You would do a restore from Sunday, then a restore from Monday, and then you do a restore from Tuesday, Wednesday, Thursday. But you'll notice that with an incremental backup, the incremental actually grows. So if we did a full backup on Tuesday, and on Monday we did 1 gig of files, and on Tuesday 200 megabytes of files have changed, our backup will be 1.2 because that's the amount of files that have changed. On Wednesday, another 400 megabytes of files have changed, so now our incremental backup would be 1.6 gigs. So with the incremental, it's actually, a pretty quick restore process because you restore the full backup and then the most recent incremental. But by Saturday, your incremental might be actually bigger than actually doing a full. So, you want to be careful of that. So some clever people came up with, hey, let's just do a differential backup. So on Sunday, again, 2 terabytes. On Monday, 1 gigabyte of files have changed because that's what has changed. On Tuesday, since there was only 200 megabytes of files that have changed, it only back up those 200 megabytes. On Wednesday, the 400, 300, 400, and 500 megabytes each day. So we're only backing up the things that have changed. It's known as a delta.
I don't think I still implement like the price. Would you give a quick example?
So you make a complete copy of your hard drive every time. So a 2 terabyte drive, the entire thing, it's a complete copy every single day. No questions asked. The whole thing goes. Okay? The incremental keeps track of the first day is 2 terabytes, so it's the full hard drive. On Monday, only the files that have changed. On Tuesday, it's all the files that have changed since Sunday. On Wednesday, it's all the files that have changed since Sunday, which is why the number keeps growing every day. With the differential, again, on Sunday, we copy the entire partition, all whatever. On Monday, we copy all the files that have changed. So what happens, we change a gigabyte worth of files on Monday. Maybe it's because we have processes that create reports for people on Monday. That's why there's always like a gig of new files. And then on Tuesday, it's just the normal day-to-day operations. You're punching away on your computer, and it generates 200 megabytes of files. So what the incremental backup does is it only backs up what has changed since the last backup. So instead of constantly growing, it just changes sizes day by day depending on what has changed. Now, the differential backup is the one that uses the least amount of room, all said and done. So I'm going to do some quick mental math here, which is going to be done out loud because I suck at mental math. At the end of the week, the full backup occupies 14 terabytes. The incremental will occupy 2, 3, 4.2, 5.8, 6, 7.7, and then you just keep adding it up. So you'll see it's still less than the 14 terabytes, but it'll end up being like, probably like 12 terabytes or 10 terabytes or so. The differential, on the other hand, will be 2 terabytes plus the 1, which is 3. Then it'll be 3.2, 3.6, 3.7, 4.1, 4.6. So we'll have 4.6 terabytes of storage used up. Significantly less, which, because disks cost a lot of money, It's the better solution. However, there's a big problem. And I'm probably actually going to talk about it on the other slides, but since it's in my brain, I'll do it now. The full backup is the fastest one to recover from. Why? Because you got a complete copy. You just copy. The incremental is the second fastest. You restore the Sunday, and then you restore whatever was the last one you did. Because it's only the difference between Sunday and whatever yesterday was, right? Differential, you have to restore Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. You have to restore them one after another, which takes a lot of time. So the differential occupies the least amount of space, but it's also the one that takes the longest to restore from. Because you can't just say, I'm going to go pull a file from Friday, because the backup itself doesn't have the full file structure, it just has the difference. So it's actually really hard to find the file, so you actually have to do a proper step-by-step restore. All right. So those are the three kinds of backups. So a bit of strategy. So ideally, we want to back up everything all the time and keep it around forever, right? Realistically, that's not something you can do. Imagine you're doing a snapshot of your entire computer every day because you just want everything. Just make it easy to get it back. And then you want to keep all these backups, these daily backups forever. My personal PC at home has 6 terabytes of disk space in it. Right? It's 4 hard drives. Well, 4 disks. Imagine if I'm doing 6 terabytes of backup daily. Where would I put that? And I want to keep it forever. Where would I keep that? And eventually it's going to, I'll owe so much money to Amazon that I won't be able to afford my mortgage. Even Amazon charges a lot for backups. So you need a combination of short-term and long-term strategies. So example, you need 3 copies of the data. In a corporation, you always have 3 copies of the data. 2 on site and at least 2, well, you have 1 or 2 on site and always 1 off site. So for example, the company I worked for, we had, like before I joined the government, we had our servers in a server room, but we also had a rack in the back of the warehouse. All in it was 1 server. Its purpose in life was to be the secondary on-site backup. So in the main server room, the server got backed up to another machine. So it was, a copy of a machine somewhere else. But we also mirrored that backup to a machine across the building so that if something went horribly wrong in the server room, we could still restore quickly from on-site. At night, we'd also run a job where the backup would be mirrored elsewhere. Before we moved to all our infrastructure to AWS, it was actually running in one of the partners' basements. It was justifying the world's fastest internet going to his house. Back then, when most of us had 25 megabit connections if we were lucky. And, he had like a gigabit connection going to his house because of the backups. So it was off-site. Therefore, if the entire building burned to the ground, we still had a copy of everything. Obviously, if the building burned to the ground, restoring the data is not necessarily priority number 1, but we have a copy of all our important data. All their accounting, all their source code, all their network infrastructure, everything's there. So we have 3 copies of the data. We have 2 hot backups for convenience. Hot backups are live backups you can just pull from. And a cold backup for insurance or disaster recovery. A cold backup is an offsite backup that you can't easily grab. It could be a hard drive sitting in somebody's drawer. You could be using Amazon S3, what they call cold storage in S3. Essentially, you upload your file in cold storage, and if you want to restore it back out of cold storage, it's so slow. It costs nothing, but it's so slow. And then you should always test the restore process at multiple levels. Like, hey, our backups run every night. It shows that it's working. Maybe we should try to restore our file out of the backup to see if the backups are good, right? You should test at multiple places. And there's other things for now talking about strategy. That cloud infrastructure is so much cheaper and so much more accessible than it used to be. One of the common things people do, and Amazon offers it, Microsoft offers it, I think Google offers it too, where you can actually back up your on-prem infrastructure into the cloud. So you run backups, but then they actually have tools that'll take these backups and copy them into long-term storage in their facilities. And that means that, hey, it's not the building that burned down. A tornado came through that whole side of town and wiped out that whole side of town. Your data is safe because it's in another city somewhere on somebody else's secure infrastructure. So, All right, so database administration support tasks include backups, offline cold, online hot. The offline cold backups isn't as common as it used to be. We used to use things called tapes. So hooked up to the servers were these tape drives, and that was the job of someone. Every day would go into the server room, eject the tape, put a sticker on it, write the date, put it in a box, put a fresh tape in the machine every morning. And when I was an infrastructure guy, we took turns. And then everybody realized I was always the first one in the building, so it was always me that wouldn't change the tapes in the morning. Right? So eject the tape, put it in the box, put it in. Tape backup still exists. People still use them. Why? It's the cheapest large volume storage you can still buy. People talk, oh, tape backups have gone the way of the dodo. They don't exist. Oh, no, they still exist. And it's still dollar for dollar the cheapest media. And normally this is done where they do a full backup on Sunday and they put it to tape. And then that tape is put somewhere else in a secure, fireproof, theft-proof facility because it's cheap. A single tape might cost $5, but it'll hold like 30 terabytes of data. But it's a tape. All it takes is a magnet, and your data's gone. So tape is good. Tape is fragile. Tapes break. If it's been in storage for too long, your tapes die. And then you reuse tapes. And after a while, they just wear out and they stop working. So there's rules like you can only reuse a tape 5 times and then you just throw it out. But you can't just throw it out because you have to wipe it first with a magnet.
How the wake up when let's say you use Amazon Web to store your documents. How that updates
So do you mean the restore part or the update?
Oh, I mean the restore part.
Yeah, I'll get to that restore in a bit. But for example, if you're trying to pull a restore from Amazon, you would use their tool chain to extract a backup. You'd copy it somewhere to your local network and then restore the backup from there. Yeah, so you just grab a copy of the backup and then you restore it. If it's on site, then you just go to the other server and you have that one less step, which is why we call it the hot backup, the on-prem backup is the convenience backup. Because we can just restore from another machine right away. When it goes off-site, you got to get the data back into the building, which, depending on what the circumstances are, if it's on a tape, you're driving somewhere to grab a tape from a storage. If it's on Amazon, you're copying it, or Azure or whatever, and you're copying it to a local server, which means you have to have enough disk space somewhere to save this temporary backup. When you plan your backup, you want to restore table spaces. You may want to use a backup restore to set up test and dev environments. Often what you'll do is you'll have a production environment, a pre-production environment, a user acceptance environment, and then the dev environment. And what you'll often do is you'll make a backup of the production environment, bring it to pre-production. Pre-production is where you test, make sure things are actually going to work when you launch. And you'll back it up off production. You'll restore it into the test or the dev or the pre-production environment. So that way, the data you're developing against or testing against is real data, not whatever, and it's the most recent data. Sometimes you'll want to do a recovery to restore erroneous data in tables. This is where I give you guys an anecdote of a day where I didn't have enough coffee when I was doing something. I needed to do some work, and it was at 5 a.m. because I needed to do it before anybody came into the office and the coffee had not hit yet. And there's a specific, because I had to test something on the live server. Like you can't test on live when people are using it. So yet I had to wait for 5 a.m., which was the window where odds are nobody was going to use it. And so we had a table called um, activation GUIDs, let's say. I'm not sure that's what it's called, but activation GUIDs essentially is a system that works to track people's software activations. And the activation GUIDs is we would drop a record in there to uniquely identify a person's session when they tried to activate, so that if somebody was trying to do a man-in-the-middle attack to figure out how to crack our activation system, if they tried to use the same GUID as someone else, it would just blow up. So for the test I was doing is I had to truncate the GUID table. However, I didn't have any coffee that day, so instead of truncating the activations GUID table, I truncated the activations config table, which is the table that actually had the configuration for all the system in it. It was not a good day for Dan at 5 a.m. when I sat there and I hit refresh on the web page and it went 500 error. I'm going, what did I just do? And I looked at the commands. I'm like, oh boy, Dan is smart. The good news is I had a backup of the database from 2 hours before. So then I restored that database into another, I restored the backup into another database and I extracted all the records and put them into the production system. That day, I saved my ass with with a backup because they always tell you don't play in prod. Sometimes you have to, and make sure you got a backup before you start playing in prod. That's all I've got to say. Yeah, I did it at 5 a.m. I did that at 5:15, realized at 5:20 what I did, and then by 5:45 I had to restore. So once I saw what the problem was, it was an easy fix. But you know, make sure you're awake before you start typing things like truncate. That's my big tip of the day. Okay, so more backup strategies. So a cold backup, it's the simplest to perform. It's perfect when the database doesn't change very often. Users can tolerate downtime. In other words, you're going to turn off the web service or the application server, do a backup, and then turn the application server once the backup is done. So that's when downtime, so you can do it at night, whatever. Hot backups, they're really difficult to do. It's better suited for dynamic mission critical databases. So if you are running an e-commerce site on your own environment and it's a site that gets traffic 24 hours a day, you probably want to do what's called hot backups. Normally a hot backup is also known as replication, where you got one server copying to another server at all times. It's live. So the good news is if you have a clustered environment, you can do a cold backup without loss of service. So a clustered environment is when you have multiple servers acting as a database server. So you've got multiple nodes. And they're always being written to at all times. You can take one of the nodes down temporarily to do a backup, and it doesn't affect the operation because the other nodes are taking up the load. And then when you bring that node back online, it gets synchronized and brought up to date. Cluster environments are the coolest thing ever. They're also the hardest thing to set up. So it's cool. So where do you store the backups? You store one on the, for talking about just about databases, you store one on the database server, hopefully on a separate hard drive. Can anybody tell me why that would be a good idea to not keep it on the same hard drive as the main system? You lose the main hard drive, you lost your backup. Too bad. Yeah, usually you do your backups to a separate disk. You're going to have it copied to another server either on-site or off-site, and to cloud storage, and probably want to make sure that's encrypted so that, if anybody gets a hold of your data, they can't do anything with it. Backed up to tape or disk. Like I said, not as common as it used to be, but still a very affordable way to do it. And you want to make sure you store to multiple locations. In other words, if you're going to do off-site, like to another server, you want to have another server in the same building and one off-site, whether it's cloud or running in someone's basement or maybe you work for a really big company with multiple data centers, like I say, a bank. So for example, the banks have data centers in Toronto and Montreal. The data centers mirror to each other in case, Toronto gets asteroid lands on Toronto. They still have their banking information in Montreal. Okay, so when you back up MySQL, what needs to be backed up? Obviously, the database content. For full backups, and those would be known as logical or physical backups. A logical backup is you dump the data. A physical backup is you're literally copying the bits on the disk. The log files. If you are worried about what they call a point-in-time recovery, which today this topic won't make a lot of sense, but when I talk about transactions in next week, I think it is, it'll make a lot more sense. But essentially, when a database server updates a record, the data doesn't always land on the disk right away. Sometimes it stays in memory, but it goes into another file called the write-ahead log. And MySQL has something called the write-ahead log. So what happens is it receives the update command. It takes the update command, stores it in a file, then it does the update, and then it writes it to the disk. And if anything happens during those steps, the write-ahead log allows you to recover, those things that haven't been written to the disk. You probably want to back up your configuration information. For MySQL on Linux, usually it's under etc mycnf or /etc/mysql/mycnf or a variety of those places. If you have any cron jobs, those are automated jobs on a timer. So somebody got clever and they called it cron, but they forgot the H for like chronometer. For things like your configuration file and your cron jobs, you might want to use a source control system to keep track of them so that, as you make changes, you have backups of it that are versioned. So in MySQL, there's something called the binary log. So just a moment ago, I was talking about the write-ahead log. In MySQL specifically, it's called the binary log. So every command that changes data gets written into the binary log. Once the binary log is executed, it will put in the checkpoint and then clear the binary log. It's not on by default. MySQL doesn't have this feature on by default because it's, again, expensive. It takes up processing. And then the update logs are created in sequence, so you'll have a 001, a 002, et cetera, et cetera. Binary logs are transaction compatible. I'll be talking about those next week. And then the actual service, the MySQL service, which is the service that actually runs MySQL, contains an index file that tells it where all the binary logs are. So you turn on the binary log if you need to be able to do what they call point-in-time recovery. So let's just say you did a backup at 7 a.m., okay? And through the day, these binary logs are going to be written one after another. And they're still on the disk. They've been written to the disk, but they're still on disk. So you have 001, 002 through the day. These files are slowly filling up with every DML command, every insert, update, or delete, truncate command. It's all going to be in these files. And then at 1 o'clock, somebody knocks on the door and says, hey, we just noticed that something has gone horribly wrong with our database. Somebody got a hold of somebody else's credentials and they decided to start going to town on the data. And they're deleting data out of the database. Now, if this is a really busy system and it's now been 6 hours since the last full backup, you have the potential of losing a lot of data. So what you'd use is the binary log so you can start playing them back, the file 1, file 2, file 3, one after another, so that you can get to the point just before the person compromised the database. So you can replay all the commands through the day until that point. It's a very expensive thing to have turned on because it adds a lot of disk operations. It takes up a lot of room. But if you're talking about it's an accounting system where the entire future of the company that revolves on the fact that this data must exist, it's probably a good thing. By the way, don't ever run an accounting system on MySQL. Don't ever do that. That's not the database to read for your choice. So in MySQL, if you want to dump the database, which is what the phrase is in database land for making a backup, it's called dumping the database. The command is called MySQL dump. Wow, they're really original, right? So the way it works is you go MySQL dump space the name of the database, and you may need to supply connection credentials like, -u root with a password or whatever. And then you use your output redirect, in this case, the greater than sign, and then you give it a file name. So in this case, it would be MySQL dump. We're backing up MyDB, and we're going to put in a file called mydb. And that gives you an idea how old this slide is. 2009-04-13. This slide has not changed since 2009 except getting a new coat of paint. .SQL. You can use MySQL dump to dump individual tables, the entire database, or the entire server. The backups from MySQL are plain text. In other words, you can open up in a text editor and see the backup. What's in it? Create table commands, insert statements, and various and sundry other things like create index, create user, that kind of stuff. What's also kind of cool is it can be used directly as input into another server. So let's say you want to copy database A database from server A to server B. You can choose to do MySQL dump. And have you guys been learning about, you guys in your, you have a Linux class right now, right? Have they talked about input and output redirection? Okay. So you've seen the pipe, right? Command 1 pipe into command 2. So that's what it's doing. Is you're taking a dump. So you're gonna dump the world database, and then you're gonna pipe it into MySQL and you give it a new host name with the name of the database, and it'll actually take the backup and feed it into the next command. So it'll actually live restore into another server right away. Just some cool MySQL tricks. That you can't do that with Oracle. You can't do that with Postgres. You can't do that Microsoft SQL Server. This is a MySQL special.
It's not safe, right?
Yeah, your data will not be stable unless you lock. There's parameters on a MySQL dump where you can do lock tables, lock database, and that will actually lock the database for write. So that means at least you'll have a currently snapshot. And again, if the database is huge, this will fail because there's only so much you can pipe. But if you're doing a small database, it's fantastic. So MySQL dump has some extra parameters. You can go single transaction. So that means that it'll dump all the InnoDB tables as a single transaction. So begin transaction does everything, and so nobody can make changes to those tables while you're backing up. Lock all tables. That's a good way to make sure your backups are consistent. But when it's lock all tables, nobody can use the system except for read. You can't update, you can't delete, you can't insert. And flush logs. So if you got the binary log enabled, if you do a MySQL dump and you include flush logs, it'll do a backup of the database, and then it'll actually grab the whatever's in the binary log that might have been created while the backup was running. So it's a cute trick. And now for restores. Okay, so a restore. It's using a backup to return the database and or server to a previous state or to recover from failure. So, if you're backing up, you have to figure out how to get it back, and that's called restore. Reasons to restore. Recovering from failure. That's pretty straightforward. Something's gone horribly wrong and now you got to restore. Creating another copy of the database. For example, you're a developer and you need a copy of the production database to make sure that your changes are going to break anything. You can grab a backup and restore it on your development environment. Maybe you need to restore to a previous state, including previous versions of the data store, correcting erroneous data, the 5 a.m. not enough coffee moment. Those are reasons why you're doing a restore. If there's some way to do something horribly wrong to a computer, I've done it at some point in my career. And it is what it is. So how do you do a restore? So to do the last full backup, you go, and if it's a backup that actually creates the database because there's parameters on there to create the database, whatever, it's MySQL, and instead of the output redirection, you do it as input redirection, which is the less than sign. So in this case, this is all assuming you're working on Linux. It does work in Windows too, not in PowerShell. Windows command prompt, not PowerShell. There's a different way to do it with PowerShell. So what it'll do is it'll read the backup SQL and feed it into the MySQL command. Sometimes you need to feed in the parameter for the username and the password. Sometimes you'll want to include the name of the database because maybe the backup doesn't have the name of the database in it. So, or it doesn't have the create database command in it. It's just create table. So you can, redirect it to a specific database if you want. And then let's just say you have all the binary logs turned on and your backup was at 2 a.m. and it's now 10 a.m. and you need to do a restore and you want to make sure you catch everything that happened during the day. The MySQL bin log will take care of that for you. It'll actually replay the binary log and you feed it one file at a time. So MySQL bin log, host name, or whatever this case is, bin.001, pipe it into MySQL. MySQL will run all the commands that were in that binary log. If you want, you can actually just run the bin log and see what the commands were yourself. Very curious on what's doing it. All right, so here's some useful URLs for you guys that will be very useful for your lab. MySQL, that is the command line tool for MySQL. You open up command prompt and you run MySQL. I go, and that one's PowerShell. Hang on, I gotta go command prompt. And my setup's a little weird. Shoot, missed it. And in this case, it's giving me an error because I didn't give it the parameters it needs. If I went dash u root, my machine's set up to allow me to log in without a password. Just saying. So this is the command line tool where I can go. There we go. Command line. Same thing you guys were doing in data grip, but command line. Old school. Okay. The other tool is MySQL admin. And MySQL admin lets you create new databases or delete databases. So again, if I go this path and I go MySQL admin, Mac users, you do not have a .exe. Just saying. If you've got a Mac, don't include the .exe. It doesn't exist. It's just MySQL admin. Okay. I'm pretty sure the labs actually highlight the fact that Macs don't use .exe. Dash u root. I want to create test database, and it just created a new database. Can I prove that it exists? Yes, because I can go test DB, and now I'm connecting to a test database. And then MySQL dump will do a backup. So if I go this command and I go MySQL dump dash u root, and let's go with flight DB. And now it's going to look like my computer's going to have a stroke. Because you'll notice I didn't add the redirect to a file thing. And, oh, that's really bad. That's definitely not the command I wanted to run. There you go, that's MySQL dump. My terminal is trying to catch up to the backup. Too much just landed into it. There it goes. It's still continuing with the backup. And it broke, actually, because the backup broke my terminal. But yeah, so, if you do a backup, this is what it looks like. And you can see I ran it again. It's just thinking really hard about it. And there it is. I'm going to do that. So I'm going to take the output of that and redirect it to flight db backup.sql. There you go. That's the backup just ran. It was like this. And if I go looking on my file system for this, turn off the preview, look for, there it is. There's the backup, 5 megabyte backup. I'm going to open this in Notepad++, and literally like drop table, create table, a bunch of inserts. It's a backup. And like I'm doing like half the lab in front of you guys. So, so if you decide you don't know how to do the lab, you can just go look at the video. It's like most of the lab is here. So let's say I want to restore my flight DB, and I'm going to restore it into that new database I just created. So if I go this one here, but I say I want to read from FlightDB backup. So I'm going to do this. Now you notice this took a little longer. There was like a slight pause. But if I go connect to that database, I can go show tables, and there's my restore. So I took the flight DB, I backed it up to a file, showed you guys that's just SQL that's in it, and then I restored it into another database. That's literally the entire lab, minus a few things where you're expected to run some commands and there's going to be some errors, or no errors. There's been some interesting side effects recently with some of the updates, and some lab instructions might be a little bit off. Should be fine. We'll pull it off. So yeah, so that is everything. That's backup and restore with demos. And it's literally that straightforward. There's nothing mysterious about it. It's just that command line. And your mileage may vary. Like for all the Windows users, I'm pretty sure your copy of MySQL is installed under C program files, MySQL, something or other. Mac users, I have no idea. It's somewhere in your path. I'm sure one of you guys will find it and then share it through Discord with everybody else. So just saying. I just don't remember off the top of my head where it is on the Mac. But yeah, so that's it, folks. That's it for today. Again, short lecture, small topic. There's nothing else to add to that, honestly. Oh yes, your final exam. Well, yeah, I'm just going to go and pull up the time for you guys for the final exam. I check your guys' final exam time through timetables, through Access, just like you guys do. All right, so for you guys, it's August 13th at 7 p.m. 7 p.m. A building. No. These are actually separated rooms now. The exams are always in a different room for some reason. So just so you guys know, I have an exam at 4 o'clock. So I got one exam, and then I'm going to be, yeah, those guys upstairs. So they're ahead of you guys, and they got an exam at 4, and then you guys have an exam at 7. So it's like 3 hours between the two. I don't know what I'm going to do for 3 hours, but whatever, it's fine. And it's in A2039. Have you guys seen the maps of the campus? There's actually campus maps that show you where the rooms are. And they're actually really good. So if you're not sure where it is, go look it up. It's basically a building upstairs from where the massage and the hairdressing people are. So you just go upstairs there, and you'll be somewhere up and down that hallway. All right, folks, and that's it. I will be going over what's on the exam eventually. It's just not today.